This is review recording 1A and B to accompany instructional recordings 1A and 1B for Section 9.1 of Mathematics 2200, Unit 9, Chapter 9. We'll review sketching the graph of a linear inequality with an example and solving a problem involving a linear inequality. Example 1. Which is the graph of 3x minus 2y less than or equal to 6? Now, if we look at all these graphs very carefully, they have exactly the same boundary. 2 are dashed, 2 are not. Well, if we look back here at the inequality that we have an equal sign. That means we must have a solid boundary. So we can right away eliminate options B and D. So it's down to either A or C. They have exactly the same boundary. We could get away with just doing a test point. A nice simple test point would be 0, 0. Let's see. Let's plug it in. 3 times 0 minus 2 times 0 less than or equal to 6. We've got 0 less than or equal to 6. That's true. The shaded region that contains our test point is in option A. Our next question is a problem-solving question. Suppose you have two part-time jobs. One is at a video store that pays $9 per hour, and the other is at a convenience store that pays $8 per hour. Between the two jobs, you want to earn at least $240 per week. Write an inequality that shows the various numbers of hours you can work at each job, graph it, and interpret your result. Okay, so there are two things we have to work on. It's the number of hours at the video store and the number of hours at the convenience store. It's the combination of those two that we always have to consider. I think I'll set up this problem a little differently than the way I did it. I did a similar problem in the instructional recording. There are two stores I'm working at, the video store and the convenience store. I work different numbers of hours, or I may work different numbers of hours at each one. So I have to call the number of hours worked at the video store X and the convenience store Y. Now the earnings from each job. That would be the rate of pay times the number of hours worked. So for example, if I worked 2 hours at the video store, I'd be making 9 times 2, which is $18. But if I work X hours, it's 9 times X for the earnings. And for the convenience store, the rate of pay is $8 times the number of hours, which is Y. Now, my earnings from the video store plus the earnings from the convenience store, that constitutes or makes up my total earnings from the two jobs combined. So that would be 9X plus 8Y. Now, we've got to have that at least $240 per week. So that $240 has something to do with it. At least means it can be equal to $240. The question is, should I use the less than symbol or the greater than symbol? At least means it's got to be $240 or more. So we need that greater than symbol. So we really have the inequality 9x plus 8y greater than or equal to 240. Now I've had to come over to this slide to do some work on graphing the boundary. Our boundary is 9x plus 8y equals 240. I'll try to graph this one by the x-intercept and y-intercept. For the x-intercept, we put in 0 for the y, and therefore we have 9x equals 240. Divide both sides by 9, and we get x is equal to 26 and 2/3. Approximately, of course, 26.7 hours. Now, the y-intercept, we put in 0 for the x. This one works out to a nice whole number. 8y equals 240. Divide both sides by 8, and we get y equals 30. Because of the numbers involved, 26.7 and 30 for my intercepts, I should probably go by at least 2's on this graph. So I've marked off my scale. My horizontal axis is the hours at the video store. Vertical is hours at the convenience store. My x-intercept was about 26.7, so that would be around about here. And my vertical intercept, my y-intercept was 30. So I draw in my boundary. I do a test point. Let's try 30 and 30. So 30 and 30 would be right here. I like to pick an x value and a y value that are the same so that I don't mix them up. And I plug that in, 9 times 30 plus 8 times 30. That's supposed to be greater than or equal to 240. 270 plus 240 is obviously greater than or equal to 240. Makes a true statement. Therefore, this is our shaded region up here. Now, interpreting our graph, if we work any combination of hours represented by a point on the boundary or above it, then we will earn at least $240. And I've written that over here to summarize. Now, there is a bit of a reality check here because there are only 168 hours in a week and you have to sleep and eat for some of them. So you wouldn't be able to necessarily work, for example, 70 hours at the video store and 60 hours at the convenience store. You probably just wouldn't get enough sleep or time to eat. In closing, to graph an inequality in two variables, graph the boundary, determine if it should be solid or dashed, and use a test point to determine your shaded region. And when solving a problem, define what your variables represent, write the inequality, graph the inequality, and write a statement that interprets your solution.